Hello everyone, +2 here. Today we are doing level 3 2025 differentiation. I reckon this year easier than previous year's exams. Today I'm gonna do a question 1. Question A, differentiate f of x 5x cubed minus 2x plus 1 to the power of 5. So obviously we have to use a chain rule, right? So we go f prime x equals 5x cubed minus 2x plus 1 to the power of 4, and then times by derivative of inner. So that's 15x squared minus 2, right? So we expand between 5 and 15x squared minus 2. So that means 75x squared minus 10 times 5x cubed minus 2x plus 1 to the power of 4. This is right. Yeah, good. Now, question B. The temperature of an oven is given by the formula this, given that T is in between 0 to 12. C is the temperature of the oven in degrees Celsius. T is the time in minutes after the oven has been switched off. Find the rate of change of the temperature of the oven 4 minutes after the oven was switched off. So what we have to do is we have to find the C prime and then plug 4 is the question, isn't it? So first of all, C prime was dc dt. So let's say C prime. So first of all, this one, before we do C prime, this equation can be written as 60t to the power of minus half plus 5t to the power of half plus 15, right? So you do need to write in index form so that we can use a power rule. So C prime, so minus half comes front, so minus 30t to the power of minus 3 over 2 plus 5 over 2 t to the power of minus half, right? So 15 is gone. Now, if do I need to rewrite? Let me think. Yes. All right, so we can rewrite as minus 30 over, I'm going to just say t to the power of 3 over 2 plus 5 over 2 square root of t, or just t to the power of half. All right, and then we plug 4 into it, so minus 30. Now, if I plug 4 into 4 to the power, square root of 4 is a 2, right? 2 cubed is 8, so that should be 8. And then this is 5 over, again, square root of 4 is a 2, so 2 times 2 is a 4. And we add them, add these two fractions. So 8 minus 30 plus 10, which is minus 20 over 8, which is minus 5 over 2, which is minus 2.5. So the rate of change is minus 2.5 degrees Celsius per, it is a seconds, isn't it? Minutes, sorry, per minute. Should be the answer. Cool. Question 3. What is the gradient of the normal to the curve when y equals sine cubed x cosine x, when x equals pi over 4? All right. So to find the gradient of normal, you have to find gradient of tangent first, isn't it? So we have to find the gradient of tangent, we have to differentiate, right? So we go, well, this is gonna be product rule. So U is sine cubed x, V is cosine x. So U prime is 3 sine squared x cosine x, right? And V prime is minus sine x. Hence, Y prime is VU prime, so which is 3 sine squared x cosine squared x plus UV prime, so which is minus sine to the power of 4x. Now, the gradient of tangent when x is pi over 4. So we plug pi over 4 into this. So 3 sine pi over 4 squared cosine pi over 4 squared minus sine pi over 4 to the power of 4. I'll let you know. So sine squared pi over 4 is the same as sine pi over 4 to the power of, squared. They are the same, okay? So anyway, sine pi over 4, what is it? 1, isn't it? Cosine pi over 4? Oh, sorry, it's not sine pi over 4 is square root of 2. So sine pi over 4 is a square root of 2 over 2, right? So we go, and cosine pi over 4 as well. That's a square root of 2 over 2, right? You can use a calculator. So a equals to 3. If I square this, I get 2 over 4, which is a half, isn't it? And cosine pi over 4 squared as well is a half. And now, if I go square root of 2 over 2 to the power of 4, which is sine pi over 4 to the power of 4, which is 2 to the power of 4 is a 16. That's a 4. It's a quarter, isn't it? So that's a quarter. So which is a 3 quarters take away a quarter, which is 2 quarters, which is half. So half, not enough space. Half is the gradient of tangent, isn't it? So normal should be, so gradient of normal should be minus 2, isn't it? Because half, which is the gradient of tangent, times by the gradient of normal, becomes negative 1. Yeah, so hence, so I'll write the answer. Let's just say answer is minus 2. All right, next. The graph below shows the function f of x, x squared plus e to the power of 2x, and the tangent to the curve when x equals to 1. Okay. Find the point P, the x-intercept of this tangent. All right. So to find the point P, we have to find the equation of tangent, isn't it? So to find the equation of the tangent, first of all, we differentiate the curve, which is a 2x plus the derivative of 2x is a 2, e to the power of 2x, isn't it? Then when x is 1, so f prime 1 becomes a 2 plus 2e squared, isn't it? So that's the gradient of the tangent, right? I'm not gonna change that to decimal. I will just leave it. So that's the gradient. Okay. So I'm gonna say y equals 2 plus 2e squared x plus c. Well, we do not know c, but we will find it out. So to find that out, we have to find y value of this point. So we know 1 comma something, right? So we will find it out. So when we plug 1 into this equation, we get 1, because 1 squared is 1 plus e to the e squared, isn't it? That is a y, right? So the coordinates of this point is 1 comma 1 plus e squared, right? So using this, let's find the c. So I'm saying so we plug 1 into x and then 1 plus e squared into y. So we go 1 plus e squared equals 2 plus 2e squared plus c, right? So we find the c from this equation. So c equals what? Minus 1 minus e squared, isn't it? So hence the equation is 2 plus 2e squared x minus 1 minus e squared, or I could say minus 1 plus e squared, right? Now, so we are almost there. So we have to find x intercept, right? So which means x intercept means when y is 0, right? So this means 2 plus 2e squared x equals 1 plus e squared. Hence, x equals 1 plus e squared over, well, this one I can factorize by 2. So 2 times 1 plus e squared, right? So that one cancels out. I mean, altogether. Hence, it becomes a half. So it turns out p, the coordinates of p is a half comma 0. Okay, so we have to say therefore p equals a half comma 0. All right, that wasn't hard. And question E, I think this is the last question of question 1. All right, question E, a curve is defined by the pair of parametric equations. X is this and y is that. Find the coordinates of any points of inflection on this curve that are also stationary points. All right. You may assume that any inflection points found are actually inflection points. You must use calculus and show any derivatives that you need to find when solving this problem. All right. So to find the points, any points of inflection, you need a second derivative, isn't it? So first derivative finds out turning points, and second derivative finds point of inflection. So we start with the dx dt. Oops. Hold on. What's okay? This is interesting. Technical issue. What's dx? Hold on. What is happening? Sorry about this. I'll try again. dx dt. dt. Right. It doesn't. dx. Okay. I'm gonna. Yeah. It's technical issue. All right. I'm gonna solve question E in next session. All right. So I'm gonna finish it here, and I will see you next time. All right. See you. Bye.